Tesla's future now hinges on a single AI chip, and it could determine the timeline for unsupervised full self-driving, the robotaxi network, and the third-generation Optimus humanoid robot. Imagine this: a tiny chip manufactured in Texas with the potential to completely transform the way we travel, work, and interact with robots. It's not science fiction. It's Tesla's next-generation AI5 self-driving chip, and Samsung has officially begun bringing it into production. What's happening behind the scenes could be nothing short of revolutionary. Discover the power of Tesla AI5 now. According to Samsung Foundry and multiple industry sources, the AI5 design has successfully completed tape-out, and Samsung's Taylor, Texas fabrication plant is ramping up production of the chip using its cutting-edge 2-nanometer process technology. This marks a major milestone, bringing fully autonomous vehicles, large-scale robotaxi fleets, and mass-produced humanoid robots closer to reality than ever before. Tesla's AI5 journey has never followed the conventional path. While competitors such as Waymo and Cruise rely on a combination of Nvidia hardware and proprietary software, Tesla has chosen a completely different strategy, designing its own AI chips from the ground up, controlling every aspect of the hardware architecture from start to finish. AI5 is the result of a close collaboration between Tesla's hardware and software teams, a rare co-design approach that tightly integrates both disciplines from the ground up. According to Elon Musk, a single AI5 chip delivers roughly 5 times the useful computing power of the dual AI4 chips currently installed in Tesla vehicles. The raw hardware improvements are even more impressive: 8 times more compute, 9 times more memory, and 5 times greater memory bandwidth. AI5 is expected to achieve between 2,000 and 2,500 TOPS, trillions of operations per second, representing a massive leap over the dual AI4 system, which delivers approximately 300 to 500 TOPS. So why do these numbers matter so much? Think of it this way: AI4 has already enabled remarkable advances in Tesla's full self-driving system, from detecting obstacles to handling complex urban driving scenarios. But there are still bottlenecks. Certain AI workloads require long chains of computations, and limited memory prevents larger, more sophisticated models from running at peak efficiency. AI5 was designed to eliminate those constraints. Thanks to deep optimization at the silicon level, some tasks that previously required up to 40 emulation steps can now be executed natively in just a handful of steps. As a result, inference performance on certain critical workloads could be 10 to 40 times faster, dramatically improving the speed and responsiveness of Tesla's AI system. One of the most remarkable aspects of AI5 is where it will be manufactured. Samsung's Taylor, Texas fabrication plant, located just about 30 miles from Tesla's Gigafactory, Texas. Samsung is doing more than simply producing the chip. It is manufacturing AI5 using its cutting-edge 2-nanometer gate-all-around process technology, one of the most advanced semiconductor nodes available. This is particularly noteworthy because the 2-nanometer node was originally expected to be reserved for Tesla's future AI6 chip. Tesla is also taking a dual-source approach to production. Samsung will manufacture the 2-nanometer version in the United States, while TSMC will provide additional manufacturing capacity to ensure the high production volumes Tesla is expected to require. James Kim, a principal engineer at Samsung Foundry, previously shared on LinkedIn that the Tesla Samsung AI5 chip has reached tape-out and would soon be integrated into Tesla's next-generation products. Although the post was later removed, the message was clear: Samsung is making a major strategic bet on Tesla. With a potential manufacturing agreement reportedly worth tens of billions of dollars through 2033, this partnership could not only accelerate Tesla's AI ambitions but also provide a significant boost to Samsung's foundry business, which has faced increasing competitive pressure. While much of the world continues to debate whether fully autonomous driving is truly achievable, Tesla and Samsung are quietly building the computing platform that could power millions of autonomous vehicles and humanoid robots in the years ahead. So, why is this chip so important? With AI5, unsupervised full self-driving is no longer a distant vision. Elon Musk has stated that the current AI4 platform is already capable of achieving safety levels that exceed those of human drivers, but AI5 is expected to take autonomous driving to an entirely new level. By supporting larger AI models, delivering faster inference, and enabling a deeper understanding of complex driving environments, AI5 has the potential to reduce the need for human intervention to an absolute minimum. The robotaxi network is perhaps the most immediate and transformative application of AI5. Tesla is preparing for the launch of the Cybercab, and AI5 is expected to be the key technology that dramatically lowers operating costs, potentially making autonomous rides cheaper than traditional taxi services. Once hundreds of thousands of vehicles can operate around the clock without human drivers, Tesla's software and mobility service revenue could grow exponentially, fundamentally transforming the company from a vehicle manufacturer into a global mobility platform. And what about Optimus? If Optimus's mechanical hardware determines how agile and capable the robot is physically, then its AI chip determines how intelligent it can truly become. That is precisely why the technology industry is paying such close attention to AI5. During the Terafab event, Elon Musk revealed that AI5 will serve as the brain of the Optimus robot during its initial deployment. As Tesla gradually phases out portions of the Model S and Model X production lines and repurposes them for Optimus manufacturing, AI5 is expected to become the missing piece that transforms Optimus from a stage demonstration into a humanoid robot capable of working continuously in real-world environments. What makes AI5 truly significant isn't simply the number of processing cores it has or the AI performance measured in TOPS. Its greatest advantage lies in its ability to process data with extremely low latency. For Optimus, the speed of decision-making is just as critical as raw computing power. A robot may be able to recognize an object, but if it takes half a second to process that information before reacting, that decision may already be too late. Whether it's carrying heavy loads, avoiding nearby people, or operating alongside high-speed manufacturing equipment, even a delay of a few hundred milliseconds can lead to mistakes, or in some cases create serious safety risks. That is precisely why memory bandwidth is such a critical factor. As we mentioned earlier, AI5 is expected to deliver roughly 5 times the memory bandwidth of AI4. This means data from cameras and sensors can be transferred to the processor much more quickly, allowing the robot to access and run much larger AI models with virtually no delay. In other words, instead of constantly waiting for data to be loaded before computation can begin, Optimus can observe, analyze, and respond almost simultaneously. The advantages of this become especially clear in real-world situations. Imagine a factory worker unexpectedly walking in front of Optimus while the robot is carrying a heavy container of components. The robot must do much more than simply detect the person's presence. It has to predict the person's path, calculate a new trajectory, and adjust its own movements in a fraction of a second. If processing takes too long, the robot may have to pause to think, slowing down the entire production line and reducing overall efficiency. But if all of those calculations are completed almost instantly, Optimus can move far more naturally and fluidly, reacting in a way that closely resembles human instinct rather than machine hesitation. This is exactly what Elon Musk has emphasized time and again when talking about the future of Optimus. The goal isn't to build a robot that simply repeats a pre-programmed sequence of motions, but to create a machine that can adapt to a constantly changing environment. No factory is ever exactly the same from one workday to the next. Components may be placed slightly out of position, shipping boxes may be facing the wrong direction, or a worker may unexpectedly enter the robot's workspace. To handle situations like these, the robot must continuously observe its surroundings, understand the context, and make decisions in real time. That's also why Tesla is investing so heavily in both hardware and AI models, rather than focusing solely on mechanical engineering. AI5 is expected to greatly enhance the next generation of robots. As we've already seen, the current version of Optimus has made impressive progress. But AI5 provides the computing power needed for real-time perception, complex decision-making, and more natural interaction. Elon Musk has previously said that AI5 is designed for both Tesla's vehicles and humanoid robots, while AI6 will place an even greater emphasis on Optimus and Tesla's AI data centers. With a chip development cycle of just 9 to 12 months, Tesla is moving at a pace that's virtually unprecedented. Of course, not everything will go according to plan. Manufacturing 2-nanometer chips requires a high yield, the percentage of fully functional chips, and cutting-edge process nodes always come with technical challenges. That said, Samsung's Taylor fabrication plant is located close to Giga, Texas, giving Tesla tighter control over its supply chain while reducing geopolitical risks and logistics delays. From a competitive standpoint, AI5 isn't just intended to outperform Tesla's previous chips. It's also aimed squarely at Nvidia and other AI hardware providers by delivering superior performance per watt at a lower cost. Musk has even said he believes AI5 could become the best inference chip for AI models with fewer than 250 billion parameters. Industry analysts expect engineering samples of AI5 to appear by late 2026, with mass production beginning in 2027. Broad integration into new Tesla vehicles and potentially retrofit upgrades could follow starting in 2028. In the meantime, Tesla will continue refining full self-driving on the AI4 platform while collecting invaluable real-world driving data. That massive dataset will help ensure AI5 is trained on billions of miles of real-world experience before it reaches widespread deployment. That's all for today's deep dive into Tesla's engineering. If you enjoy exploring the technology behind the world's most advanced factories, hit that like button and subscribe. There's a lot more innovation waiting ahead.